So, welcome to the live stream. I skipped the yesterday's live stream due to my laziness, and I have not solved any question yesterday. So, we'll continue from where we left. Okay, so in the last live stream, which was on 7th 7th of March, we were doing this question, building an aquarium. So I was not able to submit this question on the live stream, but the main idea was clear that we have to use binary search on answers. So my intuition was correct, but we had problem in solving this. I just made minor changes in that code and it got submitted. So this was the time complexity of the solution. And here are the changes I made. I changed everything to long first, and I completely made sure that the upper bound is this number. I figured this number in the live stream also, and I double checked with it. And this we were doing like linear updation after checking for a given height, and I thought that if we like sort the vector height vector and then we find the upper like the limit of the height till which we have to update, because we update from all the lower heights than the given height here. So if we find the lower bound of this mid potential answer, then we do not have to traverse the whole array and skip the elements. Like we can comment this out and comment this out. See, it is still passing because everything is sorted first here. So they are less than only. But like I find out that without like linear updation or this by first second method of updation first by sorting and then finding the hard limit is almost the same, so this was never the problem. The problem was, I think, mainly in this integer type only. The idea was correct from the starting only. So I solved this question and let's move to the next. So let's solve this. Piggy lives on an infinite plane with Cartesian coordinate. Okay. Cartesian coordinates. There are n cities on the plane, numbered from 1 to n. The first case cities are defined as major cities. Okay. Traveling. N cities numbered 1 to n. We have K major cities. Coordinates of the ith city are x, I, y. Okay. Piggy, as a well experienced traveler, wants to have a relaxing trip after whatever this is exam. Currently is in city A, wants to relax. Okay. Wants relaxing trip. He is in city A and he wants to travel to city B by air. You can fly between any two cities and you can visit several cities. You can fly between any two cities. And you can visit several cities in any order while traveling with the. Okay. Fly between any cities and initial destination is B. Initially at A. Final at B. Now the rules of travel are any two cities. Travel between any two cities is allowed. You can visit several cities in any order while traveling. Like any order of cities. In any order. Because of the active trade between major cities, it's possible to travel by plane. Okay. Formally, the price of an air ticket FIJ. Okay. So this is the costing of the tickets. If both cities are major cities, if for the all the other cases, so we should write down. And this is called Manhattan city block distance also, I think. Ij major and xi minus xj yi minus yj. Otherwise, Piggy doesn't want to save time, so his main, the primary condition is to save money, so minimum cost. He can take any number of flights, so minimize the cost. No time, no flight. 6 4 6 4. Constraints are these many test cases. Okay, what is A? A is initial city, B is final city. K is 0 to 1. And AB is the index of A initial starting point, and B is the final point. Interior coordinates are given. What to have 1 second time limit. So the n is this. So expected time complexities of n can be accepted here. N log n, like better solutions than brute force n square. So how should we approach this problem? Control. Let's see the test cases. Example test cases. First test case. These are the see the input format. T T input format is T N K A B and then X I1 X1 Y1 X2 Y2 and so on till Xn Yn for the first test case and then second then subsequent. So the first test case is here. I have to minimize the total cost. We have initial point, we have starting point. So distance in going here is 0, 0, okay. 2 units here and 1 unit here. So 1 unit in 3 unit 2 plus 1 and distance in going from cost from here to here is 2 units here 1 unit here. White is stating as 0. Minus 2. What is the x coordinate? X is 1 finally and initially it was 0. So 1 minus 0, 1 and y is minus 2. Initially it was 3. Oh, it is a major city travel. Let's write it down. We will have to find the pattern using the test cases. 6, 2, 3, 5 and the cities are, let's start 0, 0. What are the major cities? First K cities are major cities, okay. K is 0 to N. So first 2 cities are major cities. That means 0, 0 and 1 comma minus 2. So we will show major cities with this 0, 0 and 1 comma minus 2. 1, 2, 3. Minus 1, minus 3 minus 1 minus 2 minus 3 1 2 3. So 0 comma 0 1 comma minus 2 1 here minus 2 here. So these two are major cities, and let's show this with green color. The other city is minus 2 comma 1 minus 2 here, and this will be a starting point. Minus 1 comma 3 minus 1 here 3 here 2 comma minus 2 2 comma minus 2 minus 3 comma 3 minus minus 3 minus 3 minus 3. So this is our initial point, this is our destination point. So if in the given example they have chosen this path, and these two are major cities, so zero cost. And this is the Manhattan distance between these points. This is the Manhattan distance. And why have not we choose this? Because this path can lead to bigger answer if we go from line. This is the correct path. And total cost is 3 here, 0 here, and 1. 3 plus 0 plus 1 equal to 4 here. And if we try to go from this path, then what is the cost here? 2, sorry, 1 unit here, 1 unit in X, and 2 units in going down. So this path will take 2 plus 1 3, and if we go, this is not a major city, so still we will have to take the cost. If we go here or go here, or even if we try to go the destination directly, if we go here, so in X it is traveling 3 units 3, and in Y it is traveling 5 units, so total 8 units. This path will cost us 11, which is bigger than the blue path, so we cannot take this path. So we have to have a linear solution here and minimize the cost. What can be our idea? If we think of a brute force, we have a choice here, choice like for the current point we have choices of making all the transition to all the other points. Here we have a choice to go to this point, this point, and if we go suppose this point, then we have choice of coming back. But we should, if we come back, then essentially we are doing nothing. So let's eliminate this. We have, if we are on this point, then we have, like initially we are here, then we have choices of going to this point, this point, this point, this point, this point. Suppose then we go reach this point, and if we again choose this, then we essentially just started and return to the same point. So like zero displacement type, so no effect. So if we go to this point, then do not consider this many choices left. And suppose we take the next choice at this, then we have this choice, this choice, this is the point, this choice, this choice, this choice. And if we take suppose this choice, then this choice and this choice. If we take this choice, like if we try a brute force, this will lead to n square for the like recursion type. Picking up the cities, the third case. How should we process this? We can do this easily in like this manner, recursion type manner, but that can be slow. Two for loops can also be done. We try to travel a city only once. We should travel a city only once, because if we again return to the same point, then there is no like, advantage. Come start from here and somehow we reach here, and then we have all the other points as choices. And if we go again back here, then essentially we are doing nothing. We just increased our cost in traveling the cities. But suppose we can travel any city in any number of time. So this is a green point, it is a non-major city. So and this is a yellow city, meaning major city. So costing will be taken. If we take suppose a major city, then essentially we can go from here to here in zero cost. Mm, Zero. If we go this path via this path, if we directly go here, 1 unit, 2 units, here, 3 units, here, 4 units. If we go via this path, zero cost, zero cost, cost is equal to 1. So the we have to take such a path where we are traveling mostly between the major cities. Both has major cities. What can be the idea? We can do DP, include exclude logic, include this, include this. Is this a DP knapsack DP like question because we have many choices here. Include exclude logic. That will lead to n square. DP is equal to how should we approach this? We mark a visited array to get negatives. Shortest path. No. Minimum cost path. If we treat them as nodes, the given points as nodes, and we have to find the minimum. Suppose this is the weight of, so it's looking like minimum cost path from 96. What is the pronunciation? This algorithm. Dijkstra's algorithm. Single source shortest path, but we will have the shortest path in terms of the cost, minimum cost. I think this, what is the time complexity of that? Yeah, we'll have to see what was the algorithm. We will have to pay the cost. First, to Dijkstra's algorithm, I think that can be our way. We can travel from any point. How will we model this graph? There exists a path here, 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 here. So essentially, we will have to make the, how many edges we will have. 4, 5, 6 for this. Number of edges will be 6 plus 5 plus 4. So tell 1. These are 10 times. And so sum of first and natural numbers is 12 plus 1 by 2. X square. N square edges. And the Dijkstra's elbow time complexity is V plus E. So number of vertices is n and total edges will be n square. This will lead to n square. But this is one approach which can be done, but it will not be accepted, I think. This can be what like we are not utilizing the fact that there are major cities here. How should we think? I think we should try run this. One, two, three, four, five, six. These two are major cities. Initial point is -2, comma 1. So this is our source. -2, comma 1 is third city. This will be a zero cost. And we will have a priority queue in this algorithm. We will have to push a cost in the point index, point index. So priority queue. Why we have priority queue in this algorithm to sort this in increasing order of cost as we push the elements and reorder it. So initially all this infinity, and initially we will push 0 cost and index 3 here. While so then we will check all the other points. Okay, empty. This will be the current city pair cost. PQ dot front. Like the main thing is when we process the neighbors for it I is equal to 0, I is less than, and I plus plus. So if I is equal to current, then it's continue. Else it is selecting another city. Like if we are currently on this point, Then we cannot take the city. We can go to 1, 2, 4, 5. So you will have to check if hmm, what will be the cost in going there. Cost is according to this function. This function. We have to supply the current comma I as ij here. Cost comma current I is less than cost of I. Then we can take this path. We will update this. Cost is equal to cost is equal to cost. Cost is equal to. We will have to take the cost to reach till this point also now. So we will get from here like 0 plus the cost to go to point 1 from index 3. This cost. This will be current dot first. Cost will be current dot first plus cost. If we and now we will have to push this. Cost comma I. This type of logic. 0, 3. 0, 3 will be first popped out here. And then we will check 1. The cost to go from city 3 to city 1. City 3 to city 1 is minus 2, 1. Minus 2, 1 to 0, 0 is 3. So 3 like 0 total cost will be 0 plus 3, which is less than cost of I. Cost of 1. cost of 1, which is infinity. So we will update this cost 3, comma 1. And now we will check with city 2 0 plus cost with city 2 from 3. City 2 is this. So this will be also 3. Uh, this, this and this. From city 3 to city 1, city 2 distance. This will be 3 plus 3 plus 6, 6 and infinity. So we will update. I have to update it here also. 3, 6. Mark this as 6, comma 2. It is priority queue. So this will be given a lower priority. Like first this will be popped out here. It is not a stack queue. Then this is the continue city. And we will check at 4. City 3 to city 4 distances 1 plus 2, 3. This is less. This will be pushed, and this will be pushed here. 3, comma 4, 6, comma 2. Here we will have 6, comma 2. And this will be 3, comma 4. And we will check with city 5. City 5 distance with 3 is minus 4 plus 3, 7. So 7, comma 5. And city 6 distance is minus 3, comma minus 1. This one minus plus 5. So essentially it will be here 5, comma so this will be taken in next iteration. We will be at index 1. From index 1 we can go to index 2 with zero cost. Three plus mm, 3,1. And the next iteration, this will come from first index. We will try to go to index. We try to go to index 2. Then the total cost will be 3 plus 0, which is less than 6. So this will get updated. This will be pushed. So 3 comma 2 will be pushed. Comma 2 will be pushed. Okay. This will become 3. This scale will be remain 0. I think we should code this. I think this solution will not be accepted because this can give TLE and doing Dijkstra's algorithm. Dijkstra's algorithm, time complexity per bounds. V square solution. entities and where it will be zero based indexing, so we will have to take care of this. A indexing, or we should make it one indexed only. Sin, okay. Sin B. So total cities. We will have everything as one based indexing only. So we will push our dummy element at 0 index at 0 0. We have to take care of this. Extra element. So first case it is index 1 2 less than equal to k, then it will be a major city. We will have a priority q pair of int command q. We will have a vector int min cost with n plus 1, and it will be into max initially. And we will push this initial point, the a point, in the pq. Min cost a will be equal to 0 starting point, and q dot push pq dot push. 0 is the cost. First represents cost, the second is city index. So this will be A. Now we will process it and not empty. While PQ is not empty, current pair and command current is equal to PQ dot top. What will be the logic? We have to check the other cities for int I is equal to 1 based indexing n equal to n also equal to n I plus plus if it is same as current city continue. Now we will have to calculate the cost to write this function cost int I int j. Now also have to supply the cities with int and cities. We also have to supply k here. If I is less than equal to k and j is less than equal to k, return 0. Else we will have to calculate the Manhattan distance. Return absolute cities I dot first minus cities j dot first plus absolute cities I dot second cities j dot This is a constant time function. This will run in constant time. If current dot first represents cost of reaching this point plus this cost of new path and current dot second I cities k is less than min cost I. And we'll have to update this. Min cost I is equal to this. Also we'll have to push this. Push and then not popping this. Push. First will be min cost I, second will be I. capital PQB, main cost. The first test cases. Okay, four zeros. Oh, I have not printed this. This is, I think, out of the limits. We will have to make this long, long. Long, long, max. Long, long. Also long, long. It is giving correct answers. Running slow. Points. 0 major cities. Initial point, starting point. Sharing here. Maximum distance. Sum of. Overflowing somewhere. So logically it is correct, but I'm unsure whether it will pass all test cases. Let's try to submit this. And F2P. We remove the duplicates from the priority queue. Here, after here, we have to remove the duplicates. I think it will optimize it. This is a queue. Let's see the hint. I think Manhattan University. We are not utilizing the fact like the major cities. Point. We just use this cost function. Let's see the fly directly between the cities or use the major city network. Closest, we will have to find the closest major city from the current from the destination. If we go from if we find the approach to this, okay, I think I'm getting. Find the closest major city from a source. Find the closest major city from destination. So total cost will be cost A. Let this be M1, this be M2 city. Cost A comma M1 plus cost M1 M2. This will be always 0 as both are major. Cost of M2 comma B. So we have to minimize this function. This is 0, and we will have to find a city such that this cost is minimum, and we will have to find a city M2 such that this cost is minimum. And this can be done in linear times. We'll have to iterate. If we only have 3 points, this is A, this is B, this is the only major city, then this represents this, and this distance represents this part. It's a greedy problem. Greedy. It's a nice problem. So essentially the idea is now clear, I think. Good hits. The question was like pretty simple, I think. After the hints, it's very clear. Greedy approach. We will have to remove all this. We will just have this cost function in place. We will take the input. Greedy approach. Minimizing the cost by going through major cities only. So total 3 components are there. One is 0. So long cost underscore A is equal to minimum cost to go from A to B. Minimum cost from A to M. Shorter name A to M. A to M. This is initially long max. And I have to calculate it till K. If there are no major cities, then it is edge case. If there are no major cities, This is like if we have only one major city. Case 1. If we have multiple major cities here, and other cities are also there, and then we will never go to this other city. We will go closest major city, then free travel till the nearest major city, and we will just have to pay for this. So this cost and this cost. Case 2. Case 1. K is equal to 1. K is equal to 2. Essentially both are same. Conceptually, case 3 is greater than equal to 2. Case 3, 0 major cities. If there are 0 major cities, then if we go up or down, this is the starting point, this is the ending point. Manhattan distance will be this plus this. If we go here, then the first Manhattan distance will be this part and this part. The second will be this. So it is same. So we can go directly because this will be same. If the point is here, then this can increase. First we have to go here, and then this on. The cost will increase. We can go directly here and here. This will be here, this will be here, and this will be here, this will be here. So if k is equal to 0, go directly. K is equal to 0. Cost A city, B city, cities, K. The major city cost A to N first city will be E. So second will be I. We will have to get the minimum cost from here. So essentially the closest Manhattan distance will give this. We will have to search all the points because they are not sorted in any particular order. Minimum cost. A to M. We can do this search for B also in same loop. B to M cost B comma I comma cost comma comma B to M from M. Then the total cost will be A to M plus 0 highway costing B to M. So time complexity wise, this will be only 2 for loops, and that also only for major cities. So okay. We should run. No. It is wrong here. DSA NK one, here it should be one base indexing. And this is the key. One base indexing. City 0 is extra. Where it is problem. Index P index. If one of them is a major city, then it will come as 0. If the starting or initial point is a major city, then it will come out automatically 0 from here. What is wrong? Why new one output first is this? To submit this time it will be accepted. Wrong answer. I think we missed an edge case. First test case. 6 and 8 and all are major cities. 6. Total 11 cities. First 10 are major cities. And so A. This is N, this is K, this is A, this is non-major cities first. So first 6 are the major cities. minus 11,76 plus 1,63. All red points with major cities. Minus 1,63 minus 58,75. 68.21 comma 21 87.65 1 2 3 4 5 6 major cities. Now we will have minus 63 minus 63. This is city number 7. This will be 8 8 10. So 8 and 10 will be different colors. Minus 63. 66 comma minus 13. Source and our destination will be 88 comma minus 7. 84 comma minus 73. Source and destination. So we are trying to go this path, but this leads to okay. So we will have to calculate this. Minimum of this quantity comma. Okay. In case they are non-major cities and they are close enough, then going via the highway. So it is good to go in directly. This distance is directly very less than going first here to the major city and then again going to the destination. This cost plus this and this cost. Here we will only have this cost plus this cost. Okay. This should be it. Accepted. Okay, so the idea was First, we read the question, understood it, and what can be the main learning. We revised this algorithm and we predicted that this will be n square, but I still coded this up. I think because there was no idea in my mind as to what to do. Then we looked at the hints, hint 1 and hint 2. So we figured out this approach, the greedy approach. Final answer is minimum of going by the highways or directly, like this path, or we go this. Why the major cities? And we will just ignore the, we will not take any non-major city travel unless it is one involves source or destination. And these three components will give our answer, and one will be always zero because major city traveling is free. So, okay, I'm ending this live stream.